Unit 14, Part 7. So how do you say that there are even numbers and odd numbers? This is the correct way, right? You need to say it as a conjunction, right? You would go wrong if you were to try to say it like this. Right, so be very clear in your minds between the difference between this existential statement, which is here inappropriate, right? If you're asked to symbolize there are odd and even numbers, there exists an x such that x is both even and odd is wrong. That says there is a number which is both even and odd. That's not true. This is the way you would say it, right? A conjunction of existential statements. There are even numbers and there are odd numbers. There exists an x such that e is x, and there exists an x such that x is even, and there exists an x such that x is odd. Once again, this would say exactly the same thing if we replace both of these with y, or both of these with y. Right? That is to say, these pairs of x's don't connect with one another, really, because this x is bound by this one and not bound. It doesn't. This quantifier doesn't bind anything after this. The scope of this only goes to the first complete formula. It binds the first complete formula after the quantifier, which is just the propositional function, ex. Propositional functions are complete formulas, but not sentences, not true or false. And so this one binds this, right? The lesson of that example is very similar to what we went over in Unit 13. If you remember, we went through the example of how do you say that some cats and dogs are pedigreed, right? And we made an attempt, which turned out to be false, where we try to express that statement in quantifier form. Okay, so really, one of the big lessons of the third and final part of Unit 14, it's on symbolizing truth functional compounds, is that you're given English sentences, you're asked to symbolize them. Please be aware that you have truth functional combinations available to you, right? That is, don't make the mistake of thinking that for every English sentence that you're presented with, that you have to fit it into quantifier form. So there are many English sentences you'll be presented with that clearly involve the use of quantifiers. There's a some, the word some, or all, or every, or any. Any, by the way, gets the universal quantifier. Any flower will do means for every single individual flower, it is true that it will do. The predicate will do does hold. Any is universal quantifier. I've said it a couple of times because it always confuses people. People mistake the any for an existential. But it's not. Anyway, if you've got an English statement and you're asked to symbolize it, and that English statement clearly has English words which are quantifiers in it, you're right that your translation should also have quantifiers. Quantifier statements will at the very least be parts of your symbolization, but don't make the mistake that you have to have the whole thing in quantifier form, right? Don't crack your head open trying to think, how do I say that there are odd and even numbers when I try to say that and put that in quantifier form, it goes like this, right? Which, when I read it back, says there are numbers which are both odd and even, which is not the same thing. It says something false when I was asked to say something true, right? Be aware that you can avail yourself of truth functional forms, which have as parts quantifier statements, right? And again, as I mentioned in an earlier part, in Unit 15, the exercises you do, the most important ones are Unit 2, Question 2, Unit 15, Question 2 exercises, where you're given what I call pure quantifier proofs, and Question 4, where you're given mixed quantifier proofs, right? And the pure ones, all your premises and conclusion will be like this, that is in quantified form, or all the premises and conclusion will be one CQN away from being in pure quantified form. So you might have premises and conclusions like in the example we did over the first 5 parts, right, where they're negations, but when you do the CQN of those negations, the result is a formula in quantify form. Those are pure quantify forms. You'll get used to doing them in question 2. Also the unit 15 text is kind of split between these two kinds. But you also have to learn how to do proofs where the premises and conclusion are truth functional combinations of quantify statements, like this. So it's very, very important for where we're going also doing proofs, that you're quite clear on the distinction between stuff like this, truth functional statements, right? That's a disjunction, that's a conjunction, and things like this that are in quantify form, all right? But the point I'm making for symbolization, the point of section 3, main point of section 3 of unit 14, is be able to be aware that you can avail yourself of this form. So how do I say there are odd and even numbers? I have to make a conjunction, right? I have to use a conjunction, and the right thing to do is conjoin two existential statements. Isn't that weird? I've been used to doing it like this, where it's got to be in quantify form. No, it's not weird. You can do that. It's legal. You can have truth functional combinations of quantify statements. Anyway, this is the same lesson as unit 13 on complex subjects and predicates, on categoricals with complex subjects and predicates. And we wondered, how do we symbolize there are cats and dogs which are pedigreed? And if we were locked into the false thought that we had to put the symbolization in quantify form, we might try and say it like this, right? There are, or it was some cats and dogs are pedigreed. Some, so I should use the quantifier, the existential quantifier, cats and dogs, right? And the existential quantifier always goes with a dot, so my major operator is going to be a dot conjunction. Now I've got the complex subject. What is that? Some cats and dogs are pedigreed. CX, X is a cat, DX, X is a dog, PX, X is pedigreed. Right? Surely that's right, right? Because it says some cats and dogs are pedigreed. So that should be and, right? No, because you read it back, what does it say? There exists an X such that both X is both a cat and a dog, and X is pedigreed. What? That's not right. Right? That's not what I'm saying. I'm not saying that there are cat dogs which are pedigreed. I'm saying that there are cats which are pedigreed and there are dogs which are pedigreed. That's what I'm saying in the way I said that. Listen to the logical form in that. I'm saying there are existential quantifier. There are cats which are pedigreed and major operator conjunction. There are dogs which are pedigreed. Right? So that's wrong. This is right. Wrong. Right. Yes? It's a conjunction. There are cats which are pedigreed and there are dogs which are pedigreed. And be clear. When you see there are, that's asserting existence. It's an existential quantifier is called for. Just to complete the recap of that lesson, we also went up for another example, another attempt. Also, when we're still locked into the false thought that we have to fit things in quantified form, we have to fit English sentences into quantified form. You don't. You're allowed to do these. But when you think you do, maybe this should be or. And we said that was wrong because that's too weak. This says there is something which this is closer. It says something true, but too weak to capture what I originally said. This says there is something which is either a cat and a dog, and it's pedigreed, right? So this is made true by the existence of one pedigreed dog when there's no pedigreed cats. That would make this true, but my original sentence wouldn't yet be true. I said some cats and dogs are pedigreed, right? This would also be made true by one pedigreed dog when there are no pedigreed cats. But that's too weak, right? What I'm saying is I'm asserting two existence claims. Some cats and dogs are pedigreed. There exist some things like this, and there exist some things like that. I've got to avail myself of the form of this conjunction. Okay, good. Okay, I'm not going to put it up on the board, but I will say very quickly, if you look at 266, the last page, no, sorry, not 266, 268 is the last page, and Klenk runs through an example of, so just listen to this with the book in front of you. Here's the page I'm talking about. Okay. She runs through an example of how to symbolize a couple of examples. And so look at the one on the very last paragraph of the chapter, the sentence, not every politician is a crook and not every clergyman is honest. All right? So it's just identify the overall form. It's a conjunction, right? So what she does, she lays down a conjunction, and it's not every and not every. So they're both universal statements. So look at the way she lays down the form first. That's what I wanted to just mention, right? So up here. Okay, she lays down the form. It's a conjunction. It's a not all and not all, with also that the hook as the major operator of the propositional functions. Okay, and then she just subs in the things. So that's how you do it. You just have to also be aware that English sentences that involve quantifiers can also have truth functional form, right? The form of an English sentence might be a conjunction. It might be a conjunction of quantifier statements. And I should also mention, there's also the possibility of having it's a perfectly legal formula to have something like A for August. A is the individual constant for August. I'm sorry, you can see this here. Okay, this is not for all x, ax, and ma. Okay, so this is a conjunction of a negated universal and a singular sentence. Singular sentences are complete formulas. Perfectly legitimate to have a singular sentence as one of the conjuncts in a conjunction, or one of the disjuncts in a disjunction, and have the other part of the formula be a quantifier statement, the negation of quantifier statements. Those combinations are just as legal. This is perfectly fine. This says both. So A is August, MA, MX, X is American, AX, X is Australian. So what does this say? Answer, pause, welcome back. This says not everything is Australian and August is American. Right? That's a perfectly fine English sentence. That would be its logical form. Not everything is Australian. It's not the case that for all x, x is Australian. That's complete. And the other thing that's true, two things are true, I just said one of them, and the other thing that's true is that August is American, right? You'll have to do symbolizations that use this. Okay, that'll do for Unit 14.